For today, I can classify polynomials according to degree and number of terms. Let's read together. 1, 2, 3. I can classify polynomials according to degree and number of terms. So today's concept. Tell your neighbor today's concept. Polynomials, yes. And what are we doing with them? Classifying. We're going to classify them. All right. So we're moving. Bless you. We're moving on from getting stuck with just exponential expressions. Bless you, infinity. How about that? Bam. So our concept for today is polynomials. Before I get to the concept, though, I want to clarify one term before we continue. So copy the objective really quick, and then I'll go ahead and clarify the other term. Okay, we got it? Yes. All right. Now, bless you. Now think about this question. I'm going to move your screen. How do you know when a monomial becomes a binomial, trinomial, or polynomial? Yeah, hold on to that question. Hold it on in your noodle. How do you know when a monomial becomes a binomial, trinomial, or polynomial? Now, I don't want names of the others. I'm saying, think about the question. How do you know when a monomial becomes? I'm not saying how do you know when what the other ones are called. How do you know when a monomial becomes a binomial, trinomial, polynomial? We'll try and answer that by the end of the lesson. Okay? So here goes. Monomial. Don't write this down. Just pay attention. It says, a monomial is a number, a variable, or a product of numbers and variables with whole number exponents. Now, I slowed down on the reading just so that you understand what they're talking about. Here it goes again. A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. Okay. Do we understand up to right there? All the terminology. Just to clarify, does everybody understand what product means? Tell your neighbor what it means. All right, so let's clarify to make sure that we got what monomials are. It says a number. Let's see, over here, monomials, a number, yes. A variable, yes. A product of numbers and variables, yes. A product of numbers and variables with exponents that are whole numbers. Yes, there they are. Okay, everybody see that up here? Okay. So think about that definition and think about why these are not monomials. Think about that one, and this one. Talk it over with your neighbor. Tell them why each of these situations is not a monomial. Okay, let's see. Let me get started with this one. Colton, why is this not a monomial? According to the definition, why is this not a monomial? What's not a whole number? Okay, with whole number exponents. So you're saying that what's not a whole number? The -2. Hands if you agree with what Colton said. That is correct. -2 is not a whole number. Whole numbers are the counting numbers. You guys remember the first week when we covered integers and all that? Counting numbers including 0. Those are whole numbers. Is that a whole number? No. Therefore, this is not a monomial. Okay? Pass someone, Colton. go to the next one. Who? Banana? Why is this not a monomial? Because it's subtracting, and what does the definition say? Everyone? Product. So therefore, this is a difference. Okay. Okay, this is a challenge one. Let's see. Who takes on that challenge? Elias. Okay. Elias said you're dividing, but it's asking for a product. What if I wrote it like this? Isn't that a product? Will this be that? Elias? Yes. Okay, so therefore it cannot be the division part. Clarissa. The exponent on the 3 is negative. So think about it. Before it went to the denominator, what did it look like? Tell your neighbor, please. That is correct. So this was written as 2x to the negative 3. So therefore, it's not a whole number exponent. Everybody clear on what monomials are? All right, so we're not focusing on monomials today. What are we focusing on? What's our main concept? So in your prayer model, write in polynomials. Definition. Polynomials are monomials or some or difference of monomials. Polynomials are monomials or some or difference of monomials. Polynomials are monomials or some or difference of monomials. What are polynomials? Monomials or some or difference of monomials. Polynomials are monomials or some or difference of monomials. So let's understand the definition. Polynomials are monomials. Do we know what monomials are? Yes. So a monomial is a polynomial. Everybody agree so far? Yes. Or sum or difference of monomials. Picture that? Is everybody picturing the sum or difference of monomials? Yes. Kinda, sort of? Okay. Write these examples down. We'll clarify with the examples. Examples 2, x squared, negative 3x to the 4th plus 2, x squared minus 3x plus 2. Copy that, and then we'll talk about it. All right. Writing utensils down, look up to the screen. You'll finish copying in a little bit. Writing utensils down, look up to the screen, please. Here it goes. According to the definition, polynomials are monomials. Is this a monomial? Yes. Is this a monomial? Yes. These are not because they have subtraction and addition, right? But it also says that polynomials are sum or difference of monomials. So let's see. Hold on. All right. So is this a monomial? How about this one? And what's happening in between? Added, which is what? Sum. Okay. Is this a monomial? Is this a monomial? And what's happening here? Which is difference. How about, is this a monomial? And what's happening here? So therefore, it's sum or difference of monomials. Everybody understand that so far? Okay. Now, these have special names, and we're going to get to those. So the special names for these are, whenever a polynomial has only one monomial or one part, it's called a monomial. One part, one monomial, there it is. When it's two monomials or two parts, or as we say it, two terms, this is called a binomial. When it's got three monomials or three parts, this is called a trinomial. But all together, all of them, and anything after that, anything that has more parts, it's called a what? Polynomial. And let me tell you why. Look up, box this part up right here where it says poly. The word poly comes from the root word many. And the word nomial comes from the root word term. So what does that mean? Polynomials are what? Many terms. So that means that it could be any of these because it has a lot of parts. Does that make sense? Pretty simple, right? Right. So the general word is polynomials, but when I ask you independently what the name of each part is, then you'll tell me monomial, binomial, or trinomial. Okay? We got this? Some of you are like, man, it sounds like a tongue twister. None examples. Copy these down, please. Everybody done? No. Imagine if we were able to take notes as soon as we saw something, and it appeared on our paper. Damn. All right, look at those three situations that you're copying down. Start thinking, why is this not a polynomial, or this one, or this one? Now that you have that thought in your noodle, why are these not polynomials? Tell your neighbor why those are not polynomials. Everyone, why are these not? They're equations. What are we still on? Expressions. Damn, that's what I'm talking about. So with that said, hashtags. Come up with a couple, write them in there. What makes a polynomial? Hashtag what, hashtag what, hashtag what. Write those in there. Don't say them out loud. Let people think. And please don't do like last year. Somebody, oh, hashtag math. Wow. Wow. Anyways, share with your neighbor, see what they got for a hashtag. Let's see, Kenya, give me a hashtag, please. Hashtag expressions. Hands if you wrote something like that. Good. Who's got another one? Yes. Hashtag. Many terms. All right. And one more. Yes. Hashtag no equal sign. We get the idea, yes? No. All right, let's move on. So there's 4 easy steps that I'm going to give you for this lesson. Write these down. Identify the degree of each term of the polynomial. Step 2, arrange the terms of the expression from greatest to least degree and identify the leading coefficient. Step 3, classify the expression according to greatest power and the number of terms. And step 4, evaluate and simplify. Now, are you going to do all that in one problem? No. This is actually several parts that you're going to see in tonight's home plate. But I want to cover all these before you leave today. Okay? So copy that, please, so you can have that as a reference. All right. As you finish up, I want you to underline on step 2 this part. It says, and I'm going to do this in blue, arrange the terms of the expression from greatest to least degree. Arrange the terms of the expression from greatest to least degree. Draw a little arrow. This has a name. When we arrange an expression from greatest to least degree, we call it standard form. Standard form. What's that? Yeah, you actually saw this standard form in equations. They use this word a lot in math terminology to show you what a basic form looks like. So now, since we're in expressions, specifically polynomials, we're going to call it standard form when it's from greatest to least degree. Okay? So what does that look like? So let's elaborate a little bit on that. We first need to find out how to find the degree of a polynomial. How do we find the degree of a polynomial? Okay? All right, let's see. Writing utensils down, look up to the screen. Here we go. It says, the degree of a monomial is the sum of the exponents of the variable or variables. Let me repeat that again. The degree of a monomial is the sum of the exponents of the variables. Are we there? Okay, so with that said, let me zoom in. Here are my monomials. The definition says the degree of the monomial is the sum of the exponents of the variable. So here you go. I'm going to look at this one. Look up to the screen. Look at this monomial. What are the exponents on the variables? 1 and 1. But also 7 has a 1, doesn't it? Okay. So what do you think the degree is on this monomial? 2. The definition says the sum of the degree, of the exponents on the variables. Does it say on the numbers also? No, just the variable. So this is degree of 2. Look at this one. What is that degree? 4. This one. That is correct. Everybody understand what we're looking at? Okay. Now, for polynomials, the degree of a polynomial, once it has several terms, we go with the highest degree. That would be the degree of the polynomial. Okay? So check this out. Let's practice this. Let's see how this goes. Look at this one. Don't write this down. Example 1 says, find the degree of each polynomial. Of each monomial. So, don't say it out loud. Speak to yourself. Look at those 3. Do you have a number for this one already? Yes. This one? Yes. And this one? Yes. Tell your neighbor, please. 7th degree. Why? Because we add the 4 and the 3. And this is a monomial because we're still not adding or subtracting anything, right? This one is 2nd degree. Yes? And why? Because 1 plus 1 is 2. Do we add the 1 on the 7? No. And this one is the 0 degree. We got this? Yeah, piece of cake, right? All right. These next ones, copy on your paper, please. Example 1, D, E, and F. And I'm going to go ahead and forward your screen so you can give me your answers on the screen. You can write on the screen. Example 2A, write this down. Write the polynomial in standard form, then give the leading coefficient. The expression given is 6x minus 7x to the 5th plus 4x squared plus 9. Once again, the instructions. Example 2A, write the polynomial in standard form, then give the leading coefficient. Expression given, 6x minus 7x to the 5th plus 4x squared plus 9. Okay, writing utensils down, please. You'll finish copying right now. Writing utensils down. Here we go. Eyes up here. So, what I'm going to do is answer what they're asking me to do. They're saying, write the polynomial in standard form. We already know what standard form is, right? From greatest to least degree. But I'm going to show you how to do that. And second, give the leading coefficient. So what does that entail? Look up to the screen, please. Watch. According to our steps that I gave you, look at these 2 steps. I'm going to cover these 2 steps. Identify the degree of each term and then arrange the terms of the expression from greatest to least degree and identify the leading coefficient. So here it goes. Write your utensils down, and then you'll be able to copy right after. Isaac, focus, please. Here we go. So I'm going to do a think aloud. Here it goes. I need to find the degree of each term or each monomial. Let's see. This monomial is first degree. This one is fifth degree. This one is second degree, and this one is 0 degree. All right, so I did that. But then it says arrange the terms of the expression from greatest to least degree. So my greatest degree is this one, which means I need to write this one first, negative 7x to the fifth. The next one after that will be this one, so I'd write plus 4x squared. The next one after that is, and you're just paying attention right now, this one. Wait a minute, but it doesn't have a sign in front of it, but I know it's a positive 6x. And my last one is plus 9. Oh, cool. Now that is what we call standard form. Okay. But the last thing they're asking me to do is identify the leading coefficient. How do I do that? I go to my first term, and I look at the number multiplying the variable. The number multiplying the variable is negative 7, so my leading coefficient is negative 7. And this is called standard form. Copy that, please. Bam, let's go. I'm going to leave that screen up there for those of you that need to finish. But for those of you that are already done, I'm going to forward the screen to the next problem. You don't have to copy that one. I want you to write it in standard form and give me the leading coefficient. Like, oh, sorry, not that one. This one. Lock your toolbar and write it in standard form and give me the leading coefficient of what's on your screen. Copy that and go. Bless you. All right. Lastly, look up to the screen. Last part. You have to memorize the names. Okay, I'll wait. You have to memorize the names of polynomials. We already know by term, don't we? Monomial, binomial, trinomial. Yes? And anything after is polynomial. But you need to memorize the ones that come up by the degree. Degree of 0 is a constant. First degree is linear. Second degree, quadratic, cubic, quartic, quintic. And anything after the fifth degree, you just say 6th degree, 7th degree, 8th degree, and so on and so forth. You need to memorize these. Now, check this out. I put together a tool for you guys that looks like this. Degree and terms, and it creates a little grid. So check this out. So what I want you to do, you're going to arrange a polynomial. Let's say this one, look up, x squared plus 3x plus 6. In standard form. Is this in standard form? Let's see. Second degree, first degree, 0 degree. Okay. So what is the degree of this polynomial? It's the second degree, the highest degree, right? How many terms does it have? 1, 2. How many monomials? 3. So this is a trinomial of the second degree. So let's give it a name. We start with the degree. It's called a what? Quadratic trinomial. You see how that works? All right. So tonight I want you to study these and see for the home play if you can actually classify some of those polynomials. Mrs. V in the back has this little tool that I put together for you guys. It's going to be on the exit on your way out. Once again, your home play for tonight is pages 485 to 486 all, and pages 489 to 490, numbers 1 through 4, and 14 through 19 only. Have a good one, guys. There is tutoring. If I don't see you guys tomorrow. Enjoy your home play. Bye.